Now let's dig into receivers and the types of receivers that Conair has to offer for material handling. There's certain pellet type applications. Of course, we get into dealing with a lot of regrind. The recycling industry has been more and more prevalent over the years with respect to more reuse of plastics, regrind, flake, and that generates certain dust and certain other, I guess, issues that we have to deal with respect to moving and handling the resin. But also, there's filterless options. So let's dig into the first type of receiver, which would be a standard screen or mesh screen type receiver. And that's as simple as using a screen, and the mesh and the holes in the screen are smaller than the size of the pellets. So as the air passes through the receiver, the pellets either fall down to the receiver or try to pass through the mesh, and that mesh prevents that from happening. So all of that resin is going to be captured in that receiver, and the air continues to pass on to the vacuum pump, the vacuum generating pump in this case. However, what happens if you have really dusty material? What happens if you're conveying flake or sharp type of regrind that can stick into the mesh or stick into your filter media and start to clog it up over time? Now, filter receivers, if you're operating in dilute phase, very high vacuum, you're going to generate dust. You're going to degrade that material in most cases. But in this case, with a mesh style receiver, we also have a filterless receiver. This is patented by Conair, and it's a reverse cyclonic method where the material comes into the receiver and the vacuum is generated on a reverse cyclonic effect. So imagine your air is coming, or excuse me, your resin is coming in on a tangent, and your air is leaving on the reverse of that. So your resin comes into that receiver and hits a wall, for lack of a better term, just hits a reverse airstream and falls right down into the receiver, and the air continues back to your pump. Now, this will be used for applications where receivers are up on a machine without necessarily easy access, or the receivers are being utilized for dusty regrind applications or flake, or any of those reasons that you can plug that screen and have to clean it out over time. Let's pass all of that back to your central filter, and we can make modifications to those central filters to elevate them, to make much larger baghouse assemblies to be able to collect more and more dust, so your maintenance events are minimized per shift or minimized per hour, or however else you'd like to look at it with respect to rate of time. But overall, if we're looking at a screen style receiver, we've talked about filterless. Now let's talk about what happens when you're conveying microgranules or powders. Now, there's iterations to this where, again, the receiver's purpose is to separate the resin from the airflow. Now, what happens if that resin is powder? It's like you're conveying PVC powder or even finer than that. You have to separate that from that airflow. We would use a Baghouse style receiver, and this is going to be a much taller. We like to look at a 3 to 5 to 1 air to cloth ratio. Where you have a lot of surface area there to be able to collect resin throughout that conveying cycle, but these receivers are designed based on your throughput, or based on how much material you need to pull per vacuum conveying cycle. And as that starts to build up and those filters start to cake on with material, at the end of the conveying cycle, we use compressed air to blow down on those filters from the reverse side. And that cleans and that shocks those filters to be able to clean them off of their powder and have them fall down into where you'd like to convey them to your destination that you're gravity feeding now down below.